Hi everybody, in this video I'm going to go over APEX section 7.2.3 study, which is about melting and boiling points. So this is the part 2 video. If you have not already watched part 1, just pause and go back to part 1 because you need that information in order to understand this part. Alright, so we were talking about melting and boiling points and intermolecular forces, okay? So if you add a solute to a liquid, right? Like if you add salt to water, it decreases the freezing point of the liquid. It increases the boiling point of the liquid, and it decreases the vapor pressure. So we said that water freezes at 0 degrees Celsius. But if you add a solute like salt or sugar, it's going to be some sort of negative degrees Celsius. It's going to be below 0 degrees Celsius. Okay? We said that water boils at 100 degrees Celsius. So if you add salt to your water or sugar to your water, it's going to boil at a higher temperature above 100 degrees Celsius. So let's draw a little picture here to try and understand why. So the first phenomenon we call freezing point depression. Depression means it goes lower. Okay, so why does this happen? All right, well, this is our water. And when we have ice, we have water in a crystal structure, right? Because it's solid. We talked a little bit about crystal structures before. So the crystal structure of water looks kind of like this, where you have all of your pieces interacting with each other, and it sort of forms this hexagon shape. Okay, and this is called our crystal structure. Now, in order for something to melt, right, go from solid to liquid, you need to break that crystal structure. All right? So if we have, let's say we add salt, so we have Na plus and Cl minus, well, now that sodium we said is going to attract to the oxygen and pull it away. And the chlorine is going to attract to the hydrogen and pull it away. Okay? So that's going to be effectively breaking our crystal structure for us. So it's already doing some of the work for us already. So that means it requires less energy to melt. Okay? The sodium and the chlorine, our solute, is doing some of the work for us, so it requires less energy to melt. So that means it's going to melt or freeze at a lower temperature. Right? So less energy means less temperature. We remember that melting point and freezing point are the same point. So since the sodium and the chlorine are doing some of the work for us to break apart that crystal structure, it's going to melt or freeze at a lower temperature. Okay? So this is why when it's snowing, they salt the roads, because that makes the freezing point of water lower. So it's going to make it so that the ice melts, okay, without increasing the temperature, because it needs to be at even colder for it to freeze. So that's why they salt some roads. Okay, now let's move on to boiling point elevation. So boiling point elevation, that means the boiling point increases. So why is this? Well, if we have our water again, we know that the hydrogen end is attracting to the oxygen ends, right? And for water to boil, you need to break apart those interactions, okay? All right, now let's say that we add our sodium chloride. So now our sodium is attracting to our oxygen and our chlorine is attracting to our hydrogen. So we're actually forming more interactions. So that means in order to boil, you need to break this one, and this one. So it's going to require even more energy to separate this. So it's going to require more energy to boil. So that means it's going to boil at a higher temperature. Right? So the sodium and the chlorine interacts with the water, but you need to break all of the interactions for it to boil, right? For it to become a gas and they spread out. So since we are making more interactions, it's going to be more interactions we have to break for it to boil. So it's going to take more energy for it to boil, so it's going to boil at a higher temperature. So an example of this is if you salt your pasta water. So if you salt the pasta water, you might have noticed if you're boiling water and you add salt, it stops boiling, right? That's because the salt makes it boil at a higher temperature. So next time you're making pasta, notice that that happens, okay? So this is freezing point depression. When you add a solute, it decreases the melting or freezing point. And boiling point elevation. When you add a solute, it increases the boiling point. Okay, let's move on. So in order to measure this, we use molality and molarity. Now, both of these things measure concentration. Concentration of solute in solution. Okay, so we first talked about molarity, I think a couple weeks ago now, and that was moles of solute divided by liters of solution. So you're kind of comparing the part, the solute, to the whole solution. Molality, this is our new term, is moles of solute divided by kilograms of solvent. So this is comparing a part, the solute, to another part, the solvent. It's not comparing it to the whole like molarity was. They're both different ways to measure concentration of solute in solution. So let's practice using molality. So our example problem here is, what is the molality when you dissolve 5 moles of KCl, potassium chloride, in 6 kilograms of water? So we use molality equals moles of solute, that's 5 moles, over kilograms of solution, that's 6 kilograms. So you put that in a calculator, 5 divided by 6, you get 0.83 moles per kilogram. That is our unit. The other unit, sometimes they rate this as 0.83 molal. Okay? So that's how we use the molality equation. Okay, so we can actually calculate how much your melting point, your boiling point, or freezing point changes when you add a solute. Okay? So the equation we can use for this is change in temperature, F, so change in freezing point, equals I times KF times molality. Now we can do the same thing, change in temperature in the boiling point, delta TB equals I times KB times molality. Okay, so we already know what molality is. We just calculated it here. What is this I situation? Okay, so this I, it's the number of pieces your solute breaks into. Okay, so let's take a look back up here. If you had more pieces, more ions, right? Sodium chloride has 2. If you have even more, it's going to require even less energy to melt and even more energy to boil. So how many pieces your solute breaks into determines how much the temperature changes. So, for example, if you have Ki, that breaks into a potassium ion and an iodine ion. So I would be equal to 2. If you have MgBr2, that's going to break into a magnesium ion, a bromine ion, and another bromine ion. So I would be equal to 3. If you have sucrose, sugar, C12H22O11, remember is covalent, so it doesn't split into ions. It just stays the way it is, C12H22O11. So I would be equal to 1 in this case. So that I, in both of these equations, measures how many pieces the solute breaks into. Now let's look at this K. So KB and KF, these are constants. They're given for a particular solvent. And this will always be given to you. So KB and KF, like for water, if water is your solvent, the thing that does the dissolving, you'll be given KB and KF for water, okay? All right, so now let's practice applying this equation. All right, we say, what is the freezing point of a 4.5 molal solution of salt, NaCl, in water, given that Kf for water is 1.86. All right, let's look at this. So this we know is our molality. This we know is our Kf, okay? All right, our equation is delta Tf equals I times Kf times molality. All right, we have the Kf and the molality, but we don't have I. So we have to look, all right, NaCl, what is that going to break into? It's going to break into a sodium and a chlorine. So your I is 2, it breaks into 2 pieces. So now we plug into our equation. We have 2 times 1.86 times 4.5, and we plug that in a calculator and we get 16.74. Now, this is a temperature change, so it changes by 16.74 degrees Celsius. So we're not quite done yet, because the freezing point of water, of pure water, is 0. Now, the 16, when we add the NaCl, it's going to change it by this much. And remember, it's going to freezing point depression, it's going to decrease by 16.74. So now we have to say 0 minus 16.74 equals negative 16.74 degrees Celsius. And that would be our final answer. That is the new freezing point of water. Okay? Great. So from today, what we need to understand is we need to know what freezing point depression and boiling point elevation are and how they work. Why does adding a solute cause the freezing point to get lower and the boiling point to get higher? Okay. Then we need to be able to calculate molality, and notice that it is different from molarity. Okay. And then we need to be able to use this equation here to calculate the change in the freezing point or boiling point when you add a solute to your solution. Okay? All right. Thank you very much. Have a great day.